Calculus is a branch of mathematics that studies the relationship between changes in quantities. It is from the Latin word small stone. What is limit? Sometimes we can't figure out something. We try to imagine what it will be as we move closer and closer, as we approach. Okay? Hello, I am Flash Isaac, and you are welcome to my mathematics class. Today, I'll be taking you through important points in mathematics for your examination. If you've been following my videos, you notice that in some cases, I treat topics or a particular topic completely. Okay? While in some cases, I solve past questions. Some cases, I form questions and I say, okay, these are likely questions for this examination. But today, I will just bring out random points, random facts you need to know in mathematics. And you will enjoy a lot of things. So let's start from here. The basis. If I say 1 plus 1, okay, 1 plus 2, this is 3. How about I say 2 plus 1? It is 3, right? This is referred to as commutative property. Commutative. So in this case, addition is commutative. 1 plus 2 is the same thing as 2 plus 1, irrespective of the order. Multiplication is also commutative. That should become, in the sense that 1 times 2 is 2 and 2 times 1 is equals 2, irrespective of the order. How about I say 2 minus 1? 2 minus 1 is equals 1, right? What about 1 minus 2? 1 minus 2 is not the same thing as 2 minus 1. So subtraction is not commutative. This is the same thing as minus 1. When you are subtracting two numbers, if the first one is smaller than the second one, that means there will be a minus as the answer. You can take it this way. 1 like this simply is the same thing as plus 1. Then plus 1 minus 2. You can choose to interpret it this way. Plus 1, you have 1, and minus 2, you are owing 2. If you are owing 2 and you've paid 1, you still be owing 1, since the one left is not your own. So that gives us minus 1, which is similarly minus 2 minus 3 is equals minus 5. Because you are owing 2 already, you borrowed another 3. The result is still debt. You are owing debt. 9 plus 2 minus 3 times 4 plus 5. Addition and subtraction is mixed with multiplication and division. This case, you don't just answer direct, because answering direct, you will get 9 plus 2, 11, 11 minus 3, that is 8. 8 times 4, then divided by 5. So 8 times 4 is 16 times 2. That is 32 over 5. So this may not be the correct answer to this expression. So anytime addition or subtraction is mixed with multiplication or division in an expression, we apply what we refer to as BODMAS, which is bracket of or exponential, division, multiplication, addition, and subtraction. Which means there is no bracket here, no of, there is division. So you need to solve here first. Divide 4 over 5. 9 plus 2 minus 3 times 4 over 5. After division, you multiply. So 3 times 4 over 5. This will give you 9 plus 2 minus 12 over 5. What next? Addition. You can simply add here to give you 11 minus 12 over 5. Then subtraction. To subtract this, we look for the LCM, which is 5. This is something as 11 over 1. So 5 divided by 1 is 5. 5 times 11 is 55. Minus 5 divided by 5 is 1. 1 times 12 is 12. So this is equals 3, 4. That should be 43 over 5, which is different from 32/5. You see? So using the rule or BODMAS, you get a different answer from adding or subtracting direct. If I say 1 plus 1, you simply tell me 2. This is not always correct. 1 plus 1 is equals to, depending on the base you are dealing with. If you are dealing with base 10, which is the general base we deal with, 1 plus 1 is equals to, we agree. But how about we are talking about binary or base 2? In that case, 1 plus 1 is equals 1, 0. Because you can't get anything more than 1 when we are dealing with base 2. Base 2 is 0 and 1. Base 3 is 0, 1, 2 as maximum. In base 4, 3 is the maximum number you can get. While in base 10, which is our normal counting system, 9 is the maximum number. This is why we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the maximum. And everything summed up to be total of 10 numbers. S is equals to is different from S tends to 2. And it's different from S is greater than or equals to. S is equals to mean S is exactly 2. When you see S, you can replace it with 2. It also means that 2 is equal to S. But when I say S tends to 2 or S approaches 2, it means you can only put S as 2 when the expression or the equation in question is in the simplest form. That is the only time S can be 2. For example, if you are given limit question, y is equals s squared minus 4, and you are told that the limit as s tends to 2. In this case, if you say let s be 2, this will be y is equals 2 squared minus 4. This will give you 0. But putting it in the lowest form, s squared minus 4 is the same thing as s squared minus 2 squared, because 4 is 2 raised to the power of 2. We've not changed anything. And this is the same thing as s minus 2, s plus 2. Right? So having this is it's already in the lowest form. If you apply the limit and you still get 0, then fine. You know that okay, it's already in the lowest term. But there are some cases. Look at something like this. If you have over s minus 2 here, look at this. Substituting s as 2 instead of limit, you also get 0 over 0. But after simplifying, you have something like this: s minus 2 s plus 2 over s minus 2. This cancels this. The question, it becomes the limit as s tends to 2 of s plus 2. In this case, let s be 2. 2 plus 2 is equals 4. You see? So s tends to 2, you get 4. S equals 2, you get 0 over 0, which is undefined. So equal to is different from tends to. If something tends to, or it's a limit question, the expression equation or the equation equation has to be in the lowest form before you substitute the limit. Why this s greater than or equals to is an inequality. So equality, inequality. This means s can be 2 or more. So the value of 2s are 2, 3, 4, and so on, since s is greater than or equal to 2. How about we say s is lesser than or equals to? It means the maximum value of s is 2. So it can be 1, it can be 0, it's lesser than. Solving equalities versus solving inequalities. In other words, solving equations versus solving inequality. Now, we solve equations the same way we solve inequality. Pardon? We solve inequalities the same way we solve equations. Except that when you divide both sides by a negative number, the sign changes. When you multiply both sides by a negative number or sign, or the sign also changes, the inequality symbol. Look at this equation. If I say 4 minus 2s is equals 5 minus s, Collecting like terms, we simply have minus 2s plus s is equals 5 minus 4. Right? Minus 2s plus s is minus s. So minus s is equals 1. We are not looking for minus s, we are looking for s. To get s, what do? We divide both sides by minus 1. This gives you over minus 1 over minus 1. So s is equals minus 1. And minus 1 is equals s. Now look at inequality. Similarly, collecting like terms, you have minus 2s plus s is lesser than 5 minus s. Minus s is lesser than 5 minus 4 rather. Minus s is lesser than 1. To get s, we divide both sides by minus 1. But in this case, since you are dividing both sides by minus 1, which is a negative number, it will no longer be lesser than. It will now be greater than. The sign changes. So this becomes minus s over minus 1 is greater than 1 over minus 1. So this cancels this. S becomes greater than minus 1. You see, dividing both sides by negative, the sign changes. If you are multiplying both sides by a negative number, the sign will also change. Look at another difference between equations and inequalities. In equation, if s is equals minus 1, it means minus 1 is equals s. You can reverse it, but you can't reverse inequality. If s is greater than minus 1, when you reverse it, it simply means minus 1 is lesser than s. Hope you found that helpful. So when you divide or multiply by a negative number, greater than or equal to becomes lesser than or equal to. Greater than becomes lesser than. Lesser than becomes greater than, and so on. And in mathematics, there is a big difference between expression and equations. Expression and equations. In expression, there is no equality sign. If I say 2s plus 5, this is an expression. If I say 2s times 5 plus 2 all over s squared, this is an expression because there is no equal to sign. But immediately this one becomes 5 is equals 2s plus 5, or b is equals 2s plus 5. So long as there is an equality sign joining them, it becomes an equation. That is the difference between equation and expression. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. 2, 2, 2. So this is now the correct format of AP. So first term is equals A. Second term becomes A plus D, because actually A is 3. 3 plus D, which is 2, will give you second term. How about third term? Third term is simply A plus D, or second term plus D is equals third term, because 5 plus 2 is 7. So second term plus 2, which is the difference. The difference is constant. Common difference. Second minus first term, third minus second, like that. 6 minus 7, they'll give you a constant value. So that is the common difference. So the third term is second term plus common difference. And the second term is A plus D. So the third term is the same thing as A plus D, which is A plus 2D. The fourth term, T4, is third term plus difference as well, the common difference. So and third term is A plus 2D. So fourth term is A plus 2D plus D. So that is A plus 3D. Now notice something. First term is A, second is A plus D, right? Third term is A plus 2D. Fourth term is A plus 3D. When 4 is here, here is 3. When 3 is here, 2 is here, it's usually minus 1. Which means T10 will simply be A plus 9D, right? So with that, we get the formula for nth term, which is equals A plus n minus 1D. So this any number here, remove 1 from it, which means 100th term will be first term a plus 100 minus 1 d. That is a plus 99 d. This is the formula for any term of AP, and that is how nth term is arrived at. So in this case, if you're asked to look for the 10th term, T10 is a plus 9d, and that is equals 3 plus 9 times 2, because d is 2 and a is 3. This is 3 plus 9 times 2 is 18. This is 21. So that is it on AP. So let's see the next set of points. Matrix is a group of numbers or letters arranged in a rectangular form and enclosed in parentheses. So if you are given matrix, let's like this, 1, 2, 3, 4. It has rows and columns. This part is referred to as row. This is row 1. This is row 2. This is column 1. And this is column 2. Now there's something called order of matrix. Order of matrix simply speaks of how many rows does it have and how many columns. If I say the matrix is of the order 2, 2, this is referred to as 2 by 2 matrix, not 2 times 2 matrix. Okay? 2 by 2 matrix simply means this matrix has 2 rows and 2 columns. So something like this is a 2 by 2 matrix. Row 1, 2 and column 1, 2. How about I say something like this, 2, 3, 7. This matrix has 1 row and how many columns? 1, 2, 3. So since it has 1 row and 3 columns, we call that 1 by 3 matrix. How about something like this? This matrix has 1, 2, 3, 3 rows, 1, 2, 3, 3 columns. So this is a 3 by 3 matrix. And in matrix, you can be asked to look for determinants, inverts, adjoints, and so on, matrix equations. I have videos on matrix. So each of the things I'm sharing, I may be linking important videos to them. If you are watching on YouTube, you see them above. If you are watching somewhere else, I will advise you watch on YouTube so that you see the important video links at the top, so that you read the full topic, or so that you watch the full topic and full explanation. This class is limited to important points. Okay? So if I say find the determinant of this matrix, it's simply this times this minus this times this, which is 4 times 1 minus 3 times 2. This is 4 minus 6, that is minus 2. That is the determinant of this matrix. So that is it. Just to know by matrix, the meaning of rows, which one is column. So most times you may forget which one is row or column. So just do like this. So your hand is pointing towards this side. So this represents the rows. And from the top, look down. Down, the columns. Now look at this. If you have 2 over 5 divided by 2 over 4, instead of punching your calculator to say, wow, what is 2 raised to the power 5? Or what is 2 raised to the power 4? Before you now think of dividing, it's not necessary. You simply apply the law of indices, which is division law. It says, so long these bases are the same, 2 and 2, and you are dividing, simply subtract the powers. Pick one of the bases, subtract the power. So this is the same thing as 2 raised to the power of 5 minus 4. 5 minus 4, which is equals 2 raised to the power of 1 equals 2. Simple. That's the answer. You don't need to do much. While for addition, it says 2 raised to the power of 2 plus 2 raised to the power of 3, multiplication rather. This is the same thing as 2 raised to the power of 2 plus 3. That is 2 raised to the power of 5. So 5 raised to the power of 2 plus 5 raised to the power of 1 is the same thing as times 5 raised to the power of 2 plus 1, which is 5 raised to the power of 3. These are indices. Remember, indices has to do with power or exponent. And remember, any meaningful number raised to the power of 0 is equals 1. So 2 raised to the power of 0 is 1. 3 raised to the power of 0, you get 1. 10 raised to the power of 0, you get 1. 20 raised to the power of 0, you get 1. 100 raised to the power of 0, you get 1. So that is it for that. If you have something like this, s raised to the power minus m, this is something as 1 over s raised to the power of m according to indices. Meaning 2 raised to the power of minus 3 is the same thing as 1 over 2 raised to the power of 3. So which is s raised to the power of minus 1 is the same thing as 1 over s. 2 raised to the power of minus 1 is equals 1 over 2. You see? So look at this. A raised to the power of minus 4. This is the same thing as 1 over a raised to the power of 4. 1 over, if I have 2 raised to the power of minus 4, this is 1 over 2 raised to the power of 4. And this one, if you have values in the bracket, let's represent this with numbers. Let's say you have 2, and this is 3, and here is 2. You can simply multiply the powers and leave the base. This is the same thing as 2 raised to the power of 3 times 2. That is 2 raised to the power of 6. You can do that. It's permitted. And this one, do you know that s raised to the power of 1 over 3 is the same thing as cube root of s? So if I say cube root of s, it's the same thing as s raised to the power of 1 over 3. If I say s raised to the power of 1 over 2, it's the same thing as square root of s. This is why in mathematics, when they say find s, after simplifying, you have that s squared is equals, let's say 2s plus 3, or square root of s is equals 2s plus 3. In this case, to get s, we look for the square root of both sides. Do you know why? Square root cancels square. If here is square root and here is square root, s squared is the same thing as is s squared, and the square root of s squared is the same thing as s squared raised to the power 1 over 2. Like we did here, square root is the same thing as the number or the value raised to the power of 1 over 2. So if you have this, and from this power law from here, it says if you have power in bracket and outside the bracket, you can multiply them. So when you multiply this, you have 2 times 1 over 2. So s raised to the power of 2 times 1 over 2. This is s raised to the power of 2 over 2. And that is equals s. You see? So the square root cancels square. So here becomes s, and s is equals 2s plus 3. Now in this case, the s is in square root. To get s here, we square both sides. To remove square with square root, to remove square root with square. So once you square here, you square here, here becomes, this cancels this, s will be remaining. Because the square root of s is the same thing as s raised to the power of 1 over 2. Multiply by 2, 1. Okay, let's see a fraction, decimals, and percentage. Fractions are numbers that have numerator and denominator. If I say 2 over 3, this number, it has the upper part and the lower part. So this here is numerator, here is denominator, which is the lower part. Denominator, numerator. Now, if the numerator is smaller than the denominator, like in this case, the up is smaller than the bottom, we call it proper fraction. Meanwhile, when you are given a fraction and the top, the numerator, is bigger than the denominator, we call it improper fraction. You are simply carrying something that is bigger than you. So it's improper. We call this improper fraction. We have a fraction where, let's say 3 raised to the power of 1 over 2. In this case, we have a whole number and fraction. We call this type mixed fraction. Mixed. It is mixed. And anytime you are given questions in mathematics to solve, immediately you come across a mixed fraction, make sure you convert that mixed fraction to improper fraction. Because when you simplify mixed fraction, you get improper fraction. So you must convert. And how do you change from mixed fraction to improper fraction? You simply use the denominator to multiply the whole number, this times this, and the result, add it to this. You simply have 2 times 3, 6, plus 1, 7. So this is sitting at 7 over 2. Now looking at fraction, if this is a fraction, how do you convert fraction to decimal? So decimal, or numbers that have points. How do you do that? Given 1 over 2, this is obviously a fraction. If you are converting this to decimal, you do it in 2 ways. 1, anytime something is like half of something, if I say 2 over 4, this is half of this. In decimal, it will simply be 0.5. If I say 4 over 8, this is 0.5, because the top is half of the bottom. So that's 1. Look at something else. You do it this way. 1 divided by 2. Since 1 is smaller than 2, there will obviously be a 0. So you say 0 point. Now add imaginary 0 to this 1. If you add it, it becomes 10 divided by 2. And what is 10 divided by 2? That is 5. Is here. So 1 over 2 is 0.5. Similarly, 4 divided by 8, 4 is smaller, so there will be 0 point. Add imaginary 0. So 40 over 8, 0.5. So that is how to do that. How about to percentage? To convert from fraction to percentage, simply multiply by 100%. So 1 over 2 to percentage is 1 over 2 times 100%. This is 50%. 100 divided by 2. So to convert this is 2 over 4 times 100%. That is 50%. And you can break down fractions. In this case, you can break this down by saying 2 can go into both of them. 4 divided by 2, 2 over 8 divided by 2, 4. Then you can still break them down. 2 divided by 1, 2 divided by 2, 1. 4 divided by 2, 2, 1 over 2. So you can break fractions down to their lowest term. And look at something else. If I say s squared plus 4 or s squared minus 4, this is something as s squared minus 2 squared. Would not change anything. And anytime you see something like this, it is the same thing as s squared s minus 2 brackets s plus 2. So when you see something like this, you can just change it to this. They are the same. We can prove that s times s squared, s times plus 2s, minus 2 times s minus 2s, minus 2 times plus 2 minus 4. Plus 2s minus 2s, this cancels, you are left with s squared minus 4. You see, which is the same thing as s squared minus 2 squared. You need to know that. And talking about shapes and angle, if you are given a straight line, the sum of angles on a straight line is 180 degrees. Look at this. You are given a line like this, right? And it makes an angle. This is inclined. This is 90 degrees, something like this. We call it right angle. It is 90 degrees. So here is 90 degrees. If here is 90 degrees, then let's say there's another chord, more angles with the line. So theta, beta. So everything here is angle on a straight line. The sum is 180 degrees. This means 90 degrees plus beta plus this is theta is equals 180 degrees. Beta plus theta is equals 180 degrees minus 90 degrees. And if you are given one of them, let's say you are given this to be 40 degrees. Here will be 40 degrees plus theta is equals 90 degrees. That is 180 degrees minus 90 degrees. Theta is equals 90 degrees minus 40 degrees. So that is it for angles. And shapes with 3 sides and 3 angles are referred to as triangles. And talking about angles in triangles, we have acute angles. Acute angles are angles that are lesser than 90 degrees. So if you have a triangle like this, let's say 3 sides, and here is a right angle. Here is acute angle. It is lesser than 90 degrees. And we have obtuse angle. Obtuse angles are angles greater than 90 degrees, but they are lesser than 180 degrees. An obtuse angle, obtuse. Acute, lesser than 90. Obtuse, greater than 90 but lesser than 180. Reflex, greater than 180 but lesser than 360. So when you see triangles like this with one of the sides to be right angle, which is 90 degrees, we refer to this as right angled triangle. And in a right angled triangle, the longest part is referred to as hypotenuse. You see it? This part below the acute angle is referred to as adjacent, and this part is the opposite. And when you are given a right angle triangle, to solve for the missing part, we use Pythagoras theorem. And Pythagoras theorem only works for a right angle triangle. It states that in any right angle triangle, the square of the hypotenuse is equals the square of the opposite plus the square of the adjacent. Meaning if here is 7 and here is 5, to get opposite, it is simply 7 square is equals opposite square, which is the unknown, plus adjacent square, which is 5 square. So this is the square root of this, the square root of that. And in a triangle in which all the sides and angles are the same, we call those ones equilateral triangle. Equilateral, equal. So they are something like this. In equilateral triangle, you see something like this, lines of symmetry. It means all the sides are the same and all the angles are the same. And each angle in an equilateral triangle is 60 degrees. So this is 60 degrees, and this is 60 degrees. And for a circle, or at a point, if you are given something like this with various angles, at this point, everything sums up to 360 degrees. And when you are given equilateral triangle, if here is 2, here is 2, and here is 2, what happens when you divide it? Dividing here, you form a right angle triangle. Here becomes 90 degrees, here becomes 90 degrees. And dividing this angle, 60, here becomes 30 degrees, and here becomes 30 degrees. So we can use the Pythagoras theory to look for the unknown part, and this is how we arrive at special angles. So you may solve here to be root 3 or so. Then you can get sin theta, sin 30 degrees, cos 40 degrees, tan 30 degrees, tan 60 degrees, different special angles. They are gotten from isosceles triangle. When we have a scaling triangle, in that one, no sides or angles are the same. And there's another triangle where 2 sides and 2 angles are the same. Just 2 sides and 2 angles. What is that triangle called? Isosceles triangle. If you borrow money from Mr. B or from bank, you pay the person for borrowing. If someone borrows from you, the person pays you a particular amount for borrowing. So the amount paid for borrowing money is referred towards interest because there's what we call time value of money. The value of money drops with time. For example, the value of 1,000 naira 10 years ago is different from the value of 1,000 naira now. This is why when you borrow somebody, you need to pay interest. And to look for simple interest, it is simply principal times rate times time over 100. Where principal is the amount that is borrowed, rate is the interest you are paying, and time is the period the money is staying, which is usually in years. Time must be in years. This means if you are given a loan for 6 months, time is 6 over 12. That is 0.5 years. That is it. But there's another type of interest which is compound interest. In compound interest, the interest accumulates. With every year, interest increases. So you are paying interest on the interest. So this is why compound interest is equals amount minus principal. And what is amount? This is the formula for amount. So if you are given any question in compound interest and you are asked to find amount, it is simply principal bracket 1 plus rate over 100 all over n. Okay, where n can be t, time, which is the period the money is staying. Alright, now let's look at significant figure and decimal places. If I give you something like this, I say 0.004200016, and I say round this off to 3 significant figures. What do you do? Will you say 0.004? How do you do that? So this is a very important stuff because significant figures is different from decimal places. What is significant figure? When you are giving numbers, the first number that is not 0 is the first significant figure. So in this case, what is the first number that is not 0? It is 4. So 4 here is the first significant figure. Meaning, and these ones are irrelevant. No matter how many they are, the first number that is not 0, that is the first significant figure. And the second significant figure is any number after the first significant figure, whether it is 0 or not. So this is the first, this is the second. And the third significant figure is any number after the second significant figure, whether 0 or 1 or 5 or any meaningful number. So this is the third significant figure. This is the fourth, fifth, and sixth. So if we set to 3 significant figure, this is simply 0.00420. 3 significant figures. We don't need to approximate because this is not up to 5. If this were 6 or 5, we take 1 here and put here. This becomes 421. While to decimal places, to 3 decimal places, this is simply like this. 3 numbers after the decimal point. And look at this. When you are doing measurement, sometimes you are right, sometimes you are wrong, sometimes there's error. It may not be perfect. So the error in percentage is the wrong value minus the right value over the right value times 100, which is what you actually got, what you are supposed to get, and what you are supposed to get. So this is how you look for percentage error. Similarly, in business, there are profits and we have losses. So to look for profit is simply the selling price minus cost price. If the selling price is bigger than the cost price, you are making profit. But if you are selling less than how much you bought, you are running at loss. So percentage profit is profit over cost price, where profit is selling price minus cost price. Meaning percentage profit is selling price minus cost price over cost price times 100. While for loss, it's simply cost price minus selling price, because the cost price is bigger than the selling price, over the cost price times 100. So you see your loss in percent. Angles of elevation and depression. For example, if you are giving this the horizontal and this is your eye, if there is a tree here, and there is a tree, let's say, underwater, if you observe from here and you look at the tree, so the angle your eye makes with the horizontal and to the top of something, that is the angle of elevation. So if you are staying here and they say there is a tree here and the observer looks at the top of the tree, this means from here you are looking at the top of the tree. So this angle between your face, your look, and the top of the tree is the angle of elevation. While if you are standing and you are looking behind, this is your eye level. The angle between your eye level and what you are looking at, the base of something, this is the angle of depression. And if you are asked to look for the height of the tree, for example, it is simply here, which is the opposite. While here is the distance between the observer and the bottom of the tree, adjacent, opposite. While from here to the top of the tree is the hypotenuse. So solving questions under angle of elevation or depression is the same thing as solving questions under right-angled triangle. Calculus is a branch of mathematics which studies how things change. It pays attention to details. Now, calculus is from the Latin word small stone. Small stone. That is where calculus is from, the Latin word small stone. And the major areas of calculus are limits of a function, limits, differentiation, and integration. Sometimes we can't figure some things out, we can't get to the end, so we just try to look at something. What will happen as we get closer and closer to something? That is what limits talk about. So if I say find the limit of s squared minus 4, the limit as s tends to 2, this is not saying that s is equals to. It is saying that s tends to 2, meaning s approaches 2. So if you put s as equal to 2 here, do we have 2 raised to the power of 2 minus 4? This is equals 4 minus 4, or something like this. You have 4 minus 4 over 2 minus 2. If you are giving something like this and you are subtracting 2, this will simply give you 0 over 0, which is undefined. This is why if you are looking for the limit of a function, you simplify the function or the expression to its lowest term before substituting the value, because they did not tell you that s is equals to, they say it tends to 2. In this case, here becomes simplifying, you have s squared minus 2 squared over s minus 2, because 4 is the same thing as 2 squared. And in mathematics, when you have a number, the first number squared minus the second number squared, it is the same thing as the first number minus the second number times the first number plus the second number. So this is the same thing as s minus 2, s plus 2. So I proved something like this earlier. So from here, this cancels this. So we are left with limit as s tends to 2 of s plus 2. This is equals 2 plus 2, which is 4. That is the concept of limit. And in this case, you can also apply L'Hopital's rule. L'Hopital's rule states that if direct substitution gives you 0 over 0 or undefined, what you simply do is you differentiate the top separately and differentiate the bottom separately. In this case, substituting 2 directly, we have 2 raised to the power 2, 4, 4 minus 4, 0. 2 minus 2, 0. So that is 0 over 0, undefined. We simply use the L'Hopital's rule. We differentiate the top separately to have s squared. Differentiating s squared, you have 2s minus, when you differentiate a constant, you get 0. 0 over, when you differentiate here, you get 1. Differentiating minus 2, you get 0. So this is as 2s. And s tends to 2. So equals 4. You can use L'Hopital's rule or normal breakdown. And what is differentiation? If calculus is from Latin word small stone, differentiation has to do with cutting the stone to break down something to find out what it is made of. While integration is to join the stone, to bring things together to see how they build up. For example, when you differentiate a fowl, you get an egg. When you integrate an egg, you get a fowl. To show you the concept. Your kids at home, they scattered indomie everywhere. Let's call that differentiation. They hear your voice coming, mommy is coming, mommy is coming. They start arranging. So they are not integrating, they are building up. So when we have standard derivatives and standard integrals. When you differentiate a constant like 2, you get 0. When you integrate a constant like 2, you get s. Now look at something. When you differentiate 2s plus 5, dy, if y is equals 2s plus 5, dy over ds is equals 2 plus 0. Because differentiating 2s, you get 2. This is equals 2. When you are differentiating algebraic function like this, you use the power to multiply the value and subtract 1 from the power, which is 1 times 2s. Subtracting 1 from the power, 1 minus 1. That is 2s raised to the power of 0. And any meaningful number raised to the power of 0, you get 1. So that's why we arrived at 2. Now, in this 2, now they say, okay, differentiate, integrate. You've differentiated 2s plus 5. Now you are asked to integrate back. When you integrate 2, you get 2s. Now, with this integration, we've been able to recover this. We are not able to recover this one because when you differentiate a constant, you get 0. So to make up for the constant that may be lost during differentiation, we add c to any indefinite integral. So when you have this, there is no limit. Always add c after integrating. That is the reason for constant. But if you are given the limit, let's say integral of 2 ds, 2s ds, and here is 0, here is 1. When you integrate, you get 2s squared over 2. In integration, you add 1 to the power, then you divide by the power. Is the opposite of differentiation. So this is s squared. When you differentiate s squared, you get 2s. When you integrate 2s, you get s squared. Since we have limit, we simply substitute s squared minus the same s squared. In the first case, s squared is 1, the upper limit. 1 squared minus, here is 0, is 0 squared. So this is equals 1. So no need to add constant because we already have limit. So when you differentiate cos s, you get minus sin s. If you integrate sin s, you get minus cos s. If you differentiate sin s, you get cos s. If you integrate cos s, you get sin s. So they are the converse. If the integration is the converse of differentiation. So if you differentiate exponential s, you get exponential s back. So what else? We have rules of differentiation and integration, product rule, quotient rule, and so on. So like I promised, I will share a link to the full topic. This class is to cover important points, surface, key points. That is it on key points in mathematics part 1. So part 2 will be added to part 3, part 4, and part 5 to cover all the key areas you need to know in mathematics. If you enjoyed this class, why not subscribe to this channel so you don't miss out any of my videos, and feel free to check out my other released videos because you'll find them amazing. Thank you. Enjoy.